Okay, 3.2, angles and parallel lines. Postulate 3.1 says, corresponding angles postulate. If a transversal intersects two parallel lines, then the corresponding angles are congruent. And so we want to know, hey, what's angle 2 got to be congruent with? What does angle 7 have to be congruent with? Angle 4 and angle 5. These all have something that they must be congruent with because they are corresponding. So take a look. Remember, corresponding means they're in the same corner. So 1 and 5, 2 and 6, 4 and 8, and 3 and 7. Those are corresponding. So if we want to know what was congruent to 2, well, if these lines here are parallel, which these little arrows here indicate that they are, then we know that 2 must be congruent with 6, 7 must be congruent with 3, 4 must be congruent with 8, and 5 must be congruent with 1. And there's more than just the corresponding angles are congruent. It's kind of like just mark these, right? Well, we know that 1 is congruent to 5, right? And we know that 5 is congruent to 8 because it's vertical. And we know that 4 is congruent to 8 because they're corresponding and because it's vertical to 1. And if I was to just use another color, 2 and 3 have to be congruent because they're vertical. 2 corresponds to 6, and 6 is vertical with 3, which is, 6 is vertical to 7, which is also corresponding to 3. So you can kind of see a pattern here, kind of this like zigzag pattern, and that pattern is pretty consistent. So we could also know that alternate interior angles, which is what 3 and 6 are, or 4 and 5 are, alternate interior angles are also going to be congruent, and that's this next theorem. It says if a transversal intersects two parallel lines, and then alternate interior angles are, you got it, congruent. So that would mean that angle 3 is congruent with angle 6, and angle 5 is congruent with angle 4. Okay, and then this last one here, this is the only one that's a little bit different. Theorem 3.2, this is same side interior. We'll take a look. Here's my same side interior, 4 and 6, or 3 and 5. They obviously are not congruent, right? They have different different colors, different markings, right? They're not congruent. But if 1 and 2 are supplementary, and they have these two measurements of angles, whatever those measurements are, then that means 4 and 6 must be supplementary as well. And that's what the theorem says. If a transversal intersects two parallel lines, then the same side interior angles are supplementary. So that means the measurement of angle 3 plus the measurement of angle 5 would have to equal 180. And which one plus angle 4 is going to equal 180? Well, that would be the measurement angle 6 plus the measurement angle 4 equals 180. So same side interior are going to be supplementary. And we can kind of just know that that makes sense, because if you think about it, starts with an S, right? So S for supplementary, or S for same side interior. So that works for us. Alright, so let's do some practice with this. It says given AB is parallel to CD, and angle 1 is 110 degrees. We want to find the measurements of the following angles, 2, 5, and 8. Well, this is how I recommend starting this. I say you just highlight. So let me see if I can change this into a highlighter. Let's see, is this going to work? Not so much. Let me try something else here. See if this works. I don't know if that's showing up, but what I'm trying to do here is I'm trying to highlight all the angles that I know are congruent. Yeah, that's not working so great, so we'll just go back to what we were doing before. But I could circle these ones and show you that these ones are congruent to each other as well. And then we could do a little bit of math, right? So if angle 1, which is what this one was before I covered it all up, but angle 1, they said, is 110 degrees. Well, 4 is congruent with that, so that's also 110 degrees. And 5 is congruent with that, so that's also 110 degrees. And 8 is congruent with that, so that's also 110 degrees. And the red ones are all congruent. And since we know we have a straight line right here, that means that we could say 1 and 2 have to be supplementary, so they have to add up to 180. Well, that means we'd have to do 110 plus this angle equals 180. Well, that means that this angle has to be 70s, and you could just do the math for that real quick. 180 minus 110 equals 70. So here we go. Angle 2 is 70, which means that angle 3 is also 70, which means that angle 6 is also 70, which means that angle 7 is also 70. So we could fill that in pretty easily now that we've highlighted it all and kind of marked it up. What's angle 2? Angle 2 is 70 degrees. Angle 5 is 110 degrees. And angle 8 is 110 degrees. Bam. Yeah, let's go to the next page. So this is the same idea, just a little bit more going on here. They tell us that angle 6 is 47 degrees, so we want to find the measure of all the other angles. So what I'm going to do is I'm just going to use colors. Let's go to angle 6, and let's just circle all the ones that are also congruent to 6. Well, 1 and 6 are vertical, so they're the same. And 6 is alternate interior to 9, and according to our theorem, they are the same. And 6 and 14 are corresponding, so they're the same. And remember, I should have pointed this out earlier, this only works because, look, these two lines are parallel, and these little arrows here mean that these two lines are parallel. So we have a whole system of parallel lines here. So let's keep marking the ones that are congruent. Well, 14 corresponds to 16 and is alternate interior to 11, so those are congruent as well. And 11 corresponds with 3, and 3 corresponds to 1, so we know they're congruent. And 8 is alternate exterior to 11, vertical to 3, and corresponding to 6, so we know that it's congruent as well. So all those angles that are in red are 47 degrees. And that means that all the other ones must be their supplement. And remember, we find the supplement by doing 180 minus the number that we're trying to find the supplement of. And so we just do some basic subtraction, and we get 133. So now let's do all the ones that are the supplement in blue, right? So, and that's just going to be all the ones that are left. But we could do all the same logic. We could say, hey, look, 4 here is vertical to 7. 7 is corresponding to 5, which is vertical to 2, which corresponds to 10, which is vertical to 13, which is corresponding to 15, which is vertical to 12. You know, so we can do all the same logic, and we find out, hey, the blue is 133 degrees. So it's pretty easy when you look at it like that. Just usually get out your highlighter and highlight all the ones you know that have to be congruent. Okay. The reason why this problem looks all pixelated is because I copied it off of a test, and it's a good test question. It's one you might see, and so I want you to see how to do it. Here's what I do for a problem like this. I'm going to actually just create another line that goes right through this intersection, and let's just assume that this is a straight line. I know that my drawing is not the best, but yeah, let's just assume this is a straight line. And now I have 3 lines that are parallel. Well, if these two top lines are parallel, then that means this angle here corresponds to this angle here, and they must be congruent. So I'm going to say, hey, this angle right here is 125 degrees. Well, that means this little angle in here has to be the supplement of 125. Well, to find a supplement, remember, we just do 180 minus the number we're trying to find the supplement to. And 180 minus 125, we get 55. So this is 55 degrees. If this whole angle here is 119, and this little angle here is 15, we can find this angle over here by doing 119 minus 55. So let's do that. 9 minus 5 is 4, and then 11 minus 5 is 6. So we know, hey, this angle right here has to be 64 degrees. Okay, well, take a look at this. Remember we said this line and this line are parallel, and that means that angle 1 and this 64 degree angle must be corresponding angles of parallel lines, therefore they are congruent. So we could say, hey, angle 1, that's 64 degrees. Now let's say they wanted you to find this angle here. Well, again, we just have a straight line, and that means whatever angle is over here needs to be the supplement of 64. So we could do that pretty easily. 180 minus 64. Do the math. 116. And there we go. We have all of our angles. So this isn't that tricky of a problem, but I think it makes it a lot easier when you just add this line down the middle. It just makes your whole world a lot easier. So just remember to do that when you see a problem like this guy. And I think that's it. There's a summary here. If you were given the value of one angle formed by a transversal of two parallel lines, could you find the rest of all the angles? If so, how? So you need to be able to describe that to me. That's a good little question for you. But other than that, we're all done.